Hello everyone. This lesson we're going to talking about the relationship between voltage and the current in three-phase system in a delta system. So here I have a delta system for the supply. It's three-phase 240 volts. Because each of the lines is connected through my generator's coil in parallel, this line voltage from line A to line C will be the same phase voltage from my generator, these 2 points. So this phase voltage and the line voltage, they are in parallel. We know parallel circuit, the voltage will be the same. So I have the relationship, the line voltage going to equal to the phase voltage in a delta system. Now, let's look at the current relationship. My line voltage here is 240 volts. I have 3 loads, each is 24 ohm. Also connected delta, connect onto my line. Because my load is delta, so the line voltage will equal to my phase voltage down here. Line voltage 240 volt. Each phase voltage going to be also 240 volt. But these 3 phase voltage gonna have 120 degrees apart. To find my phase current in phase A, I use phase A's voltage divided by the phase A resistance. 240 volts, 0 degree, divided by 24 volts, give me 10 amp at 0 degree. My phase C current is going to be phase C voltage divided by phase C resistance. 240 volt, 120 degree, divided by 24 ohm, give me 10 amp at 120 degree. Now we look at this junction down here. My line current for line A is going to this junction. My phase current for phase A, which is measured by this ammeter, gonna come out from this junction. My phase current for phase C, which is measured by this ammeter, gonna go into that junction. So by Kirchhoff's current law, the current going into the junction will equal to the current come out. So to find out my line current here, my line current A is going in, gonna equal to the current come out. The phase A current subtract another current going in, the phase C current. So phase A current subtract phase C current. This current is all vectors. So we have to use vector to do those calculations. Phase A, 10 amp, 0 degree. Phase C, 10 amp, 120 degree. When we subtract them, we get 17.32 amps at the negative 30 degree. The 17.32 is equal to √3 times 10 amp. So the relationship between current is my line current in a delta system going to equal to √3 higher than my phase current. If we look at this phasor diagram, here's my phase A current at 0 degree. Here's my phase C current at 120 degree. When these 2 phasor current subtract each other, we get a line current. It's going to be √3 longer than my phase current and at direction of negative 30 degree. As an electrician, we don't worry about the degree of the current too much, but we have to know the current in the line is going to be √3 higher than the phase current. The delta, the last letter in the delta is a A. This A in the electrical trade, we usually representing a current. So it also gives us a hint. In delta system, the current relationship going to change by A. So the line current is going to be √3 higher, but the voltage is going to be equal. So now we complete both Y and the delta system, the current and the voltage relationship. You should be able to analyze the circuit for our next lesson. If you have a question, you can connect us online and send us an email.